and a very warm welcome, and it is a warm welcome down here in Southeast London, to our latest Talking Industry offering, which is about maintenance 4.0, in other words, digital approaches to maintenance. Before we start proceedings, I'd like to thank the sponsors of these panel discussions, which we run approximately monthly. We're sponsored by the Drives and Controls exhibition, #1 event for automation, power transmission and motion control, and it will next be taking place on the 4th to the 6th of June 2024 at our favourite venue, the NEC in Birmingham, and it's in association and part of Manufacturing and Engineering Week 2024. It's can be found, more information can be found on a website, drives-expo.com, and in due course I'll put this information into the chat for everyone. So welcome to our attendees. My name is Andy Pye. I'm consultant editor at DFA Media Group, and we produce a range of online and printed publications in the manufacturing and automation sector. For this morning, we have 3 excellent speakers with complementary and slightly overlapping approaches to digital maintenance, and I will quickly introduce them in reverse order. The first one being John, we're going to call him John E, and he will pronounce his surname correctly, I'm sure. He's, more importantly, Professor of Digital Engineering and Head of the Centre for Digital Engineering and Manufacturing at Cranfield University's School of Aerospace, Transport and Manufacturing. And he will be talking in 3rd place, but by no means last, on asset management, data modelling, machine learning, digital twins and augmented reality. So some pretty advanced concepts there. Before him, we have David Roddis, who is from the MTC, where we held our last live Talking Industry, which was just over a month ago, which was great fun. We had a keynote speaker and three panels talking about various aspects of manufacturing. Dave is the senior advisor in digital transformation at the MTC. He's got 25 years experience in engineering, quality, manufacturing. Doesn't look old enough, Dave, but there we are. And his expertise runs from the shop floor up to managerial levels. So he's got a great deal of wide-ranging experience, which will be very useful. And he's going to focus on condition monitoring, and how to turn it into a continuous process, how to use sensors, particularly how to add technology onto legacy equipment, which many businesses are using these days. And we'll look forward to hearing more from him. And in our first speaker is Richard Jeffers, and he is the founder and managing director of RS Industria, part of the RS group, and he's focused on digital approaches for maintenance. And he's going to talk to us about the culture of predictive maintenance and the sort of wider business plan type levels to start with. So that will make an ideal introduction for us. And then subsequently, he's got some more advanced technology that he'll talk about later on. So the way we work, as I'm sure you know, those of you who've been to these before, is that we try to have an interactive discussion between our panelists and also with our audience involved. So we want to encourage you to put your questions into the chat, or comments. Anything like that would be welcome. If it's a question you want us to raise, if you can prefix it with a Q colon, that certainly helps to weed out the questions. And we also do have the ability to invite our attendees to speak to the panelists. So if you want to ask a question and would like to do that, then please make that clear in the chat as well. If you've got any kind of objective comments or sources of information that you think are useful, both our panelists and our attendees are welcome to do that, so that we can create a a compendium of useful information. The only thing we ask is that please don't put commercial information in if you're here as an attendee. That's restricted to our panelists for obvious reasons. So without any more ado, I will hand over to Richard for the first presentation.
Good morning, everybody. Good to talk to you about one of my favourite topics, the digitisation of maintenance. So before we get into the digitisation of maintenance, what is maintenance? What are we trying to do in the world of maintenance? So maintenance is the process of keeping plant and equipment in good working condition so that efficiency is retained and the life of that asset is increased. And the thing about maintenance is it's not actually that complicated, but what it is really hard work to get it right every day consistently. And there sort of seem to be 4 generations of maintenance going back to the Second World War. The first generation of maintenance was very much reactive or time-based maintenance, and there was really no underpinning understanding of reliability theory and why components failed. And that was why the strong belief that it was about time-based maintenance. And then in this, moving into the second generation of maintenance in the 50s, 60s and early 70s, there was an emerging understanding of reliability theory, very much driven by the civil aerospace industry, and a growth of preventative maintenance moving away from just purely time-based. And that led to an increased asset reliability, lower cost of ownership, and particularly important in the civil aerospace, a reduction in aeroplanes falling out of the sky. And then after some really seminal work done by 2 guys called Nolan and Heap, starting in 1968 and concluding in 1978, was the development of the 3rd generation of maintenance and reliability centre maintenance, and the real development of the underpinning understanding of reliability theory and how and why components failed in use. And that led to the growing use of condition monitoring, condition-based maintenance, and predictive maintenance. And really, the theory has been pretty much understood since probably John Mowbray's RCM2 book, published in the early 90s. But what's happening now is the development of the 4th generation of maintenance, in maintenance 4.0. And that's driven by the deployment of technology into things we've understood how to do for 50+ years. But now the technology makes it easier to deploy. The falling cost of that technology also makes it easier to deploy into lower cost and low criticality environments. And so what we see now is the sort of technology that was traditionally only available in the aerospace industry or high value fleet operations is now being able to be moved into broader manufacturing environments. And the thing that really underpins the whole world of condition monitoring is that understanding of how components fail. And as I said, led by Nolan and Heap and repeated on numerous studies since, is the understanding that actually only between 10 and 25% of components fail for time-related use. The other, 75 to 90% of components fail for random reasons. And so condition monitoring, predictive maintenance, is all about measuring a leading indicator of that random failure in a cost-effective, reliable way, so that the cost of measuring that leading indicator of failure is significantly lower than the impact of that failure, making it cost-effective to deploy the technologies. And as I said, the falling cost of technology, and I'm sure David will build on this, means that some of those technologies that were only applicable for really high-value assets are now applicable for much more routine assets. But so why doesn't everybody do this? Why have we not just embraced predictive maintenance? I was in a manufacturer of it was an aerospace manufacturing business last week. The very sector that created predictive maintenance, and I was actually arguing with some of the leadership team there about why time-based maintenance of their machine tools was value destroying, not value creating. And even though that sector, is the birthplace of predictive maintenance, there's still a real lack of understanding about the value of predictive maintenance and a perception that predictive maintenance is expensive. And the perception is that planned maintenance or even reactive maintenance is cheap, and reliability centre maintenance, predictive maintenance is expensive. But the reality is very, very different, because down at that lower end of maturity, in the planned and even worse reactive world, it appears cheap because the upfront investment is low. But the reality is very different. You've got a high cost of spare parts, a high cost of labour, a high cost of finished goods to protect your supply chain from disruption, and worst of all, high personnel and operational risks, because invasive reactive maintenance is probably the most dangerous thing that you can do in a manufacturing environment, because it's by its nature unplanned. And once you move into the world of predictive maintenance and reliability centre maintenance, yes, there's an upfront investment to get there. But the reality is you then start to have low cost of spares, low cost of labour. You can push down the cost of your finished goods. And most importantly, everything is in control. Everything's done in planned time. So it's intrinsically safer. And that's why, for me, the emergence of digital technologies is so exciting. Not because it creates a new world of maintenance, but because it allows techniques that we're tied into very high value sectors now to be able to deploy it into the average manufacturing site.
Thank you, Richard. I have remembered to unmute myself, which is a rarity. That's really interesting, because I was going to say, you said that the basic theory goes back to 1968, and my, original first question was going to be, why is it taking so long to put into practice? And you have partly answered that, to be fair, but then you did say that even in the industries where they were leading these technologies, such as aerospace, there are still pockets where it's not being adopted. So what do we need to do, is the question, to get these techniques more widely adopted? And with maintenance 4.0, more technology, maybe more fear coming on stream, does that make it easier or harder? I'd like to sort of bring in the other speakers first, Richard, and then you can come back and conclude the answers. So, David, is that something you'd like to comment on?
Yeah. I mean, the obvious one for me is education. Education of your leadership. The business leaders really need to start to understand the benefits of the digital age. If you're not bringing in digital and using digital tools, you're starting to fall behind your competition. And there's a real need now for the business leaders, your leadership team, to understand the benefits of digital. Otherwise, how are you going to bring in these improvement projects if you don't understand the benefits? And they do improve your business. So I think really it's education of the leadership team, and then through bringing in the right skills within the business to then manage these new technologies.
Yeah, I would echo that. I think the skills development and looking at this in a sort of strategic way, from the leadership to the sort of mid-managers to those maybe coming into the organizations, how do we have this pipeline and this ability to make decisions from a digital 4.0 type perspective? I think that's really something that we need to focus on, to be able to have continuous transformation of businesses. And I'm sort of suggesting going beyond ad hoc introduction of technologies to having a culture where you're embracing new technologies coming into the organizations.
Yeah, we almost call it looking at things with a digital mindset. Everything with a digital mindset. I mean, even when we're talking about maintenance now, but you're capturing data, you want to use that data throughout the business, because it's not just about maintenance of the machinery. You could start looking at utilization. So it really is about understanding as business leaders how you bring that that information into the business, and really start to look at everything with a digital mindset, because it's using data to manage your business better.
John, I mean, you're involved with an academic organisation, so you're training young engineers, but no doubt you have lots of interactions as well with more senior people. How do you keep up to date, and how do you keep your students up to date, and how do you influence the culture in a more senior managerial environment?
Thank you for that question. So we, as Cranfield, we're a wholly postgraduate university. So we also very much focus on working closely with industry. So just as an example, we've got an MSc called Digital and Technology Solutions, which was developed with over 25 companies that actually shared the kind of skills requirements that they have. So I think the approach we're taking is very much along the lines of continuous communication with industry, trying to understand the requirements, trying to understand where the skills requirements are over time. And we do that by having the regular advisory boards and engagement with research projects as well. That's also a really interesting way to understand the needs. So we try to have that continuous loop between the research that we do and the education that we provide.
That's a great answer. I mean, one of the perhaps it's unwarranted criticisms of academia in fast-moving technology areas is often how do they keep up with developments in technology? And I mean, this is one of the fastest moving technology areas. You know, and then you have the issue of standards lagging behind technologies as well. So there's all these kind of difficulties in the background of knowing how to implement something that's as new as Industry 4.0, or is it new, in fact?
It is hugely challenging, and I think the key thing here is that we continue the communication. We sort of ensure that we're designing and developing future technologies and not necessarily stuck in what's available today. So we need to solve today's challenges, but we also need to be a step ahead so that we've got the competitive edge.
Yes, yes. I mean, you've described a very good process where that's a really good way of by working closely with, you know, relevant organisations. That's how to develop it, I guess, and take it from there. We had a poll that just flashed up, Andy, and it was about, you know, what level of usage are our attendees making? Here it is. So do you currently rely on time-based maintenance? And of course, we'd have lots of fun if we could break this down into different sized companies and different sectors and that sort of thing, which we can't. But as a general thumbnail, it seems to be pretty equally divided between people using time-based maintenance, not using time-based maintenance, by which I assume they're more advanced, and a hybrid approach. Richard, does that sort of fit in with what you expect people to say?
Yeah, I think, you know, for me, there is still an over-reliance on time-based maintenance in most factories that I go and visit, and people, you know, not understanding the failure modes that are impacting the assets, and therefore using maintenance approaches that are actually going to induce early life failure rather than, you know, predict a random failure event. And actually, the oldest piece of research I found on this was actually from 1943, and it's the performance of a B-24 Liberator squadron on anti-U-boat patrols from Northern Ireland, and a guy called Waddington, who was a operational researcher, demonstrated that the most unreliable time that the aircraft could possibly be was in the immediate aftermath of their planned maintenance, when they'd taken the airplane to pieces to find out why it wasn't broken yet and inserted loads of early life failure. And actually, the longer time between scheduled planned maintenance events, the higher the availability and reliability of those airframes were. That's demonstrating that the time-based maintenance they're doing is value destroying, not value creating. And I see that in a lot of our customers now. And I think just to build on the question about how do we get people to understand and embrace these technologies, I'd agree completely with John and David's point around the education around digital. But I think for me, you've got to underpin that with the education around reliability theory as well, because otherwise you digitize something you don't understand.
Yeah, fabulous. Right, well, we actually have a question coming in, which is a good point for me to emphasize that we welcome questions from our attendees, so please don't be shy. And one person who's not being shy is actually one of our colleagues, who's Aaron. and Aaron is asking a question that says, and let me get this right. So I'm trying to do 20 things at once. Right, would the panel agree that although rightly we need to focus at developing skills at university education, one of the biggest issues facing skills is a lack of technicians coming through at further education level who will be hands-on with the digital transformation taking place in manufacturing? Who would like to take that one?
I'd be happy to make a start, if that's okay. I think, looking at this, there is clearly a need and there is a lack of technicians coming through in this space. But I'd like to look at this as we've got the challenge of making decisions at strategic, operational, and tactical levels. Digital has to contribute at all of these levels. And I would suggest we need to look at this holistically. We shouldn't necessarily hone in just to technicians. If you ask me, we need to look across those levels. And if we look at the senior leaderships, I often hear from pretty much most companies that there is serious skills gaps in the leadership level as well. So my sort of proposal would be that we don't just hone in at one level. We need to look at this at all levels, and we need to sort of consider how we have this ecosystem trained at a sufficient level.
I mean, presumably, one of the critical levels are older engineers, because these are the guys who've seen the light and want to retire early. Tempted by COVID and various other factors, no doubt. So is that where one of the biggest gaps is, perhaps, rather than younger technicians coming through?
I think technicians coming through are embracing technology. They're using it every day. And I think one of the things we talk about putting it through education, but industry will drive the requirements of what skills are needed, and that should push education to provide the right courses. But there's an element around, there are other ways of gaining those skills. Even if you're bringing in the technology and using the company that provides that technology to help educate the people who then got to use it. I mean, businesses will spend a load of money on a brand new fancy machine with all the new technology and all the systems on it and provide very little training. It'll be a one-day training course on how to press the main buttons to make it work. But what they really don't do is embed it into their maintenance schedule, embed it into the capture of digital information to then use to help run that machine effectively and make it a real value asset. And there's a real gap. So I think industry's got to drive the requirements and look at other ways of gaining those skills. You can't just expect education is going to provide the right courses.
I mean, one of the things that always bothers me, and not just even in engineering, but we have a skills gap, and then you've got this time lag between being able to solve the skills gap and or train enough people to fill the skills gap and having the gap. So, what's the solution to that? Is it bringing people in from other countries and outside, or how do we deal with it?
I think you've got to tackle the skills gap at every level, as we've said. For me, equally as important to the people at the hands-on level who are doing the activity is actually the people who are making decisions about long-term asset management, long-term investment strategy. Because if you've got the SMEs bottom up pushing, but they're pushing against people who don't believe, then actually you're never going to see the value. You've got to make sure that that the senior leadership in the organisation see the value of moving to data-led decision making. And drive lead the cultural change around data-led decision making. As much as the people at the bottom, and I'd agree with David's point around the technicians coming through are digital natives. These guys are tech savvy, but they don't necessarily understand the business context that they can drive value out of the technology. So you've got to educate at both levels. You've got to get the business leaders, demanding and leading the way on data-led decisions. And then at the bottom, people who've got the skills to create the data. And the answer can't be to constantly suck people in from other economies, other businesses. It's got to be about investing in that capability in UK PLC.
It's got to be top down driven, really. They need your leadership to build a digital strategy as part of their whole policy deployment. How are you going to manage your business? How are you going to manage your assets? And beyond maintenance, your whole process is you back to that, looking at everything with a digital mindset.
I like to make this differentiation between an effective strategy and an efficient process. The leadership influences an effective strategy, which could potentially make in the order of 30 to 70% improvement in processes. An efficient process is where you can actually push the boundaries for a good strategy. So in that sort of context, maybe you're achieving 10, 20, 30% improvements, but you need these to be hand in hand, designed, developed, and I think digital is an enabler for this.
Okay. Another thing that comes up is the issue of merging different groups of engineers within one organization, because we have the tech savvy group coming through, and some older people with lots of experience but perhaps aren't quite so comfortable with the technologies. How do you merge those cultures together in a most effective way? Anyone got any experience of that as a problem or an opportunity?
Often putting the older engineers to work with the grads. I mean, as an older engineer myself, it's a mindset, it's a culture thing as well. But a lot of engineers still want to be problem solvers, and working with the younger grads who have got a different mindset, who are more technology biased, work with it and all day long, and everything's tech for them. It's just sort of putting those two together, and that often works really well, bringing in some young grads and fresh thinking to look at different ways of problem solving.
And I guess they can learn from each other in a way.
Yeah, I would agree with that. I mean, in the courses we've got, we have young sort of new graduates and those that are quite experienced. And what we've done is we've put them into groups. And what happens is they realize what each person's good at. And then they start to build these complementary teams and skills. And they learn from each other and appreciate each other more than before. And I think that's also really valuable. Instead of separating them, it's much better to sort of bring them together.
Yeah.
Okay, perhaps at this point we've got quite a few questions coming in, but they might be best taken a little bit later on. So let's move on to David's piece about condition monitoring, and specifically, but not exclusively, about the issue of legacy equipment and how we might deal with that.
Okay, so I think sort of as Richard sort of alluded to, condition monitoring is really about understanding your equipment. So if you take a sort of machine inspection or a test like a car MOT, that's a snapshot in time of how that machine is currently performing. Once you've done that test, that's it. Until somebody comes along and looks at another piece of scheduled maintenance on that machine, you just run it. The beauty of conditional monitoring is it gives you real-time information, so you can start tracking trends and patterns within the performance of that machine. So, and you can do that through a lot of either built-in sensors on newer equipment, but there's a lot of off-the-shelf additional sensors now, magnetic vibration sensors, there's pipe clamps that will measure flow, you can measure pressure, you can get cameras that will look at old analog gauges that will actually turn it into a dashboard, so you can put parameters in there. So you can now get real-time information on a regular basis. You don't want to overload yourself with every millisecond, but the right level of information gathering to look at the performance of that machine. So now you can start to see if motors are getting hot, you're getting additional vibration, because you'll start to see wear. That can then lead that once you start to read and gather more information, you can then move it over towards predictive maintenance when you start to see trends in temperatures rising on certain pieces of equipment or additional vibration. You can now plan and schedule and predict when something's going to fail. Because if you're a manufacturer, the worst thing you can get is an unplanned failure. That disrupts all of your production scheduling, you're letting your customers down. So a consistent production schedule where you're meeting all your customer requirements works around properly planned maintenance based on predictive information that you can get from these sensors. And there's a lot of simple now software that you can get that will take the data from the sensors, interpret that, turn it into a dashboard that for a few £100 you can put a fairly comprehensive system together that will give you really useful information. And if you had nothing before, even if it's legacy equipment and you get some basic information on whether you're running current, pressures, temperatures and vibration, you start to get a real visual on how that machine's performing every day, real time.
In terms of investment in new machinery, I mean, in the UK is often cited as a classic example of where we tend to make do with older equipment, and we tend to be quite proud of making do with older equipment. Actually, you know, I remember running my Ford Anglia into the ground, and it was 35 when I finally parted with it. But in other countries, the culture is rather different, and they're very proud of their new equipment. So we have quite a major issue with solving problems on legacy equipment, don't we? So how easy is that now to extend the life of legacy equipment by getting meaningful data out of it?
It's now really simple. There are lots of different off-the-shelf sensors, you know, that you don't need to drill into a pipe and then to fit different gauges and electronic gauges. You can put a clamp sensor onto it and it will read the flow. So the legacy equipment now with magnetic sensors that you can put onto the side of a motor, it's really easy. And there's a lot of simple software now that will take that data and just turn it into a nice, simple visual dashboard. A few £100 per sensor, few £100 for the software. You know, start with your critical equipment, pick your the most critical equipment, start with one or two pieces of machinery. But it's really easy now to start building, and then you need people to look at that data, but you can then build those patterns of how that machine's performing. And as I said, a lot of the time, if it's well maintained, it will keep running. It's the catastrophic failures that often cause significant damage to a machine that then put it out of commission and could be out for a long time, and then you're going to struggle to get spares. Where a lot of basic maintenance, just checking on temperatures and pressures, you could keep that machine running for a long time.
Right. Well, Sanjay has put a question into the chat, and I guess it's a curveball for you, David, but we'll get everybody else to comment as well. And he wants to know, as a customer, how he can implement maintenance 4.0 in his industry. And he says, is there any list of products with applications available for implementations? And what would the return on investment be? Well, how long is a piece of string, I suppose, but you might have a better answer.
Yeah, you need to know the impact of the cost of what your runtime per machine is, the lost time for unplanned maintenance, how old your machine. I mean, it is a real broad question, that, but I mean, it depends how long your machine, how old it is, how easy it is to get spares. Have you got spares on the shelf? If you haven't, how easy is it to get those spares? And again, these unplanned events are the ones that really cost you a lot of time. How long will that machine be down? Then works out how much disruption to your manufacturing. Have you got to put additional overtime on to catch back up? Are you going to lose customers and upset customers? Have you got penalties for being late? There's cost penalties for being late. Introducing Industry 4.0 is relatively easy. You just need to understand the benefit. We're back to that leadership understanding the value proposition for doing this sort of thing, and consistent production is one of the key things. You don't want unplanned failures, but there's so much a list of things. There's loads of companies, and I'm sure Richard would be quite happy to put a list on of products that they did, but there's lots of companies now producing, sensors that are really easy to install, easy to gather the information with software that supports it, that you can then visualize that. And it's, for several machines, a few £1,000s. Well, how much do you lose for one machine being down per hour? and you can calculate what a machine run rate is. Might be 500, 800 pound an hour run rate of a machine, depending what products it's making. So it doesn't take long that if you can save a few hours of unplanned downtime, your system's paid for itself, you know, in saving one breakdown.
We've just completed some research in partnership with the IMechE based on 700 returns from engineers within the UK, and we asked about the average cost of downtime and the amount of unplanned downtime that's experienced. So and that came back with the average unplanned downtime was 20 hours a week, and the average cost of downtime was £5,000 an hour. My background's in food and bev. £5,000 seemed not unreasonable. So you know that's £100,000 a week or £5 million a year that you're losing for unplanned downtime. And if you're operating at a margin of 10%, return on sales, you've got to make £50 million worth of incremental sales to recover the lost impact of that downtime. And if you're talking as David is about spending several £1,000s on a sensor, if you could just cut that by 1%, suddenly the return on investment starts to look pretty eye-watering.
That's a staggering figure, Richard, isn't it? I mean, because you're talking £5 million for one company.
Yeah.
Understood.
Exactly.
You've looked at 700 companies, so if that's the average.
Yeah, my colleague John will stick it in the chat, link to the research whilst we're.
Yeah, I mean that's really valuable because if ever you needed an incentive to get involved to a greater degree, that's got to be it. And it actually answers a question that appeared in the chat, which is what is the total national cost of unplanned downtime? Well, you're at least part of the way there to being able to answer that question, and it's absolutely horrendous, isn't it?
It is. I mean, back to how do you start with this stuff? Our tagline is start simple, grow smart within my team, and someone's put in the importance of starting with criticality. Everything in asset management starts with criticality. Find the machine or the process that causes you the most pain. Our first ever deployment was in a food factory, and it was on the wastewater treatment plant, because the site GM was getting fed up with being spanked by the Environment Agency about non-compliance issues. So that was the biggest, most critical asset. And for under £10,000, we were able to get the live data to allow him to bring that process back in control. So yeah, that's the way to approach it. Criticality, start with critical assets, and then just start small and grow. Don't get wrapped up in some global digital transformation, because you'll never deliver any value.
Brilliant. There is a comment as well in the chat that's just appeared, and actually the chat's having a good conversation with each other, which I always like. That says £5,000 loss in downtime amounts to 30 seconds in a car plant. So
I mean, you can calculate once you start understanding your machine runtime, but you really just need, every business is different. You need to understand the impact of which machine or which machines, the knock-on effects. But beyond the value, you're even looking at your brand reputation with your customers. If you're missing delivery dates repeatedly for unplanned downtime, your reputation is falling with your customers and winning new work. Now, that's not necessarily easily measurable, but it's quite significant in the damage that it can have if you're not meeting your delivery schedules. Because winning new work is another element. So beyond the additional costs of sort of downtime is the wider aspects.
John, you've been sitting there while our industrialists have been chatting away, but what's your experience?
I think from my side, we first need to decide what value are we trying to create. Now, in the kind of examples provided, I think we've been thinking about machines that are constantly in need to be operational. But this debate, I think, in terms of how do we trade off between corrective maintenance, preventative maintenance, coming back to, I think, what Richard was also talking about with reliability, we need to base our thinking in terms of what is the optimized way to create value from maintenance? I think it has to sit at that level. And in that process, you're trying to decide how much supply side activity you're going to need. Supply side meaning the resources that you're consuming, spare parts, people, facilities, all those kind of things need to be optimized. And I think coming back to the discussion on ROI with return on investment, we really need to think about how much investment are we making in maintenance, and what sort of benefit are we going to get in terms of the value that we're creating. So in some situations, and not very often, sometimes having corrective maintenance where you're responding to failure might be the only way that you can deal with it. And it's not often, but what I'm trying to allude to is we need to have that strategic planning process for what type of maintenance is needed in what type of scenarios.
What about, I mean, clearly you're going to need to create some sort of business plan, as David said, which is specific to any particular organization. But is there a template available that people could work with, or should they come to you, David, or to you, Richard, or to you, John? And
they need to speak to us.
Help.
Yeah, I think they need to. Every business is so different that it's too generalist to put it out. The key, as Richard said, is and we look. What's your critical equipment? What's the sort of thing that's really going to damage your production if it's not running? So you start looking at the critical items, the high value items that are really going to damage your production and have the biggest knock-on effect. And really start there. And even if it's 2 or 3 pieces of equipment to start with, you'll really start to gather that information. And that's the first thing, really. Start getting some information in to see how these machines are running. But it's using the data as well. It's not, we're all talking here about maintenance, but you can start looking at the effects. The data that you gather is usable throughout the business. So when you're looking at the machines running and what they're consuming from power, you can also look at utilization. Is it actually, how often is it actually running? So you can start to gather information from that. You can put part counts and downtime codes against it. The operators can fill in if the machine stops. So you start to build in some downtime analysis. You can start building in a bit of a basic OEE. Now you've taken your maintenance data and added to it that you're actually starting to get some really usable information to build that business case for why you should be repairing this machine or why you should be rolling out to other equipment, because you're really starting to see the effects. You could look at air pressures and temperatures. Does that have a detrimental effect on the quality of the products that you make? And that information that you can add builds that bigger picture to really start to understand the value of maintaining your equipment and working within certain parameters to control the quality of the product using the data that you're getting.
So the more use you make of your data, the better return you get on it. And that will be a big aspect, I'm sure, of what John is going to talk about in a minute, and all the different ways of collecting, gathering, utilizing data, and what you can do with it, including some of the advanced methods. Before we move on, I think it would be a good time just to mention a couple of posts from Magdi, who says, first of all, just mentions a comment from the first part, which is that he or she believes that fear and a shortage of educated leaders can be attributed as reasons for certain challenges, and I think we agree with that. But makes the point, which is important, that after the pandemic, there has been a noticeable increase in the adoption of predictive maintenance practices and the implementation of IoT technologies. So the pandemic, in effect, was a driver. And then goes on to say in a further post that they have installed, prior to the pandemic, vibration sensors on 20 machines using IoT technology. So that pretty much backs up your point, David, about the ease with which this can be done on legacy. And this implementation brought significant benefits as it allowed us to remotely monitor vibrations and detect critical conditions. Our leaders were delighted with the solution as it eliminated the need to send engineers on site, which is another important thing, unless a critical condition was identified through vibration remote monitoring system. So that's a really good case study and justification for what we're all promoting, I think, in this presentation. But has it been your experience that the pandemic was a driver in greater utilization? Well, John's nodding, so I'll go to him first and then come to the others.
I think what the pandemic has done is really escalate the digitalization processes. It's pushed companies to be more flexible, more open for working remotely, for sort of collaborating as well. And I think it's really positive that IoT is spreading. It's really good to see that condition-based maintenance is growing. If you look at one of the biggest challenges in maintenance is that we have a lot of uncertainty around reliability, and the sort of maintenance requirements over time are highly uncertain. So if we can reduce the uncertainty, it will only help to improve the way the asset's health is managed. It will also have a huge sustainability impact in terms of potentially extending the life and getting more value out of the assets that we have. So I think it's been very positive from a maintenance perspective and in terms of improving the use of digital technologies.
Richard, your comments on that?
I think it's. I'm probably just going to build on David and John's point. Actually, I don't think I've got anything additional to add.
Absolutely great. Yeah. So we're pretty much covered there. We've got some questions coming in on data risks and so on, which I'll defer for the time being, and ask John now to take the conversation on in terms of the process of getting data and how all the different technologies, including advanced methods of what you can do with them.
Perfect. Thank you, Andy. So I think before I jump into technologies, I just want to set the context. So in the context of maintenance, we're interested in balancing supply and demand. I think that's really at the heart of this. If we're doing too much maintenance, it means we're potentially harming the value that we're creating. The machines or the assets are not available for use as much as they should be. So what I mean with the supply and demand, just to break it down, demand could be things like the availability of the assets and how we're using them to create value. And supply is more on the side of making people available, making maybe spare parts available, making facilities available. So having a balance between the supply and demand is critical so that we're making this profitable, we're making this meaningful to the customer. So now if I move towards technology, technology has to enable the balance between supply and demand. If I've got too many spare parts sitting over a long duration time, I've actually invested a lot of money, which isn't maybe creating value. So how do I now have this balance between supply and demand? And that's where technology should be positioned. So if I can't build that link, I can't make that justification for the return on investment. So there's lots of really exciting activities going on in terms of technology. So if I talk about, for example, I'll start with ontologies. Ontologies are a way of semantically structuring data. Now, one of the things that we want to move into is maybe automation in data analytics. So in the context of condition-based maintenance, if I'm collecting all this information, I need to be able to cope with the amount of information that's coming in. So how do I now structure data? How do I actually feed the data into the models, into different stakeholders so that they can access it, view it? Ontologies could play that role in terms of structuring the content, making sure that we have the data accessible and we're actually feeding this in an automated manner. I think the other thing which is exciting about machine learning is we've been working with numerous companies where they often say that they don't have good data. They say that, particularly in the context of legacy assets, when you go back 10, 20, 30 years, the data isn't necessarily mature. So the potential and the kind of work we're looking at the moment is, could machine learning fill data gaps? Could it actually solve messy data scenarios whereby we can still create value from the data? We can maybe improve predictability from a reliability perspective. We can improve maybe the resources that we need to align to the future activities. So machine learning could have that role so that we're improving our data analytics, we're improving our decision-making capabilities. And another area which is getting a lot of attention is digital twins. So I would say that the opportunity with digital twins is particularly in the context of how do we build two-way communication between, let's say, a physical asset and a digital environment. So let's say that the physical asset is the machine that's critical in the shop floor. My digital asset is replicating that machine, but it's also now trying to optimize how I'm using that machine. And as it's doing that, it's actually providing feedback back into the machine. So it's adjusting the way the machine's being used. So maybe we don't use the machine at its full operating capacity. We reduce it, but ensure that we get to the next maintenance cycle. But in that process, we're not stopping manufacturing. We're sustaining the sort of manufacturing capability. So digital twins are really exciting in terms of how do we build that communication from our models, from our predictions back into the physical assets. And I think the last area that I want to touch on is around augmented reality. So the exciting thing with augmented reality is that we're making data accessible to people that need to use the data. So we're actually overlaying the data where the person needs it. So if it's a disassembly type activity, or if it's an assembly type activity where maybe there's some complexity, maybe it takes quite a long time to train someone or to gain the experience. In those kind of scenarios, we've experienced something of the order of 30 to 60% improvement in the time it takes to do things like diagnosis or disassembly type activities. So a potentially hugely financially advantageous technology. So the key question there is, how do we align data? How do we make the ability to overlay content in this whole process so that it's efficient and it's actually able to overlay the type of content that we need? So again, very exciting, lots of work to be done in that space, but it's got lots of potentials as well. So this is my sort of take on it, just a few examples, but I'm very excited in terms of where we can use digital technologies to enhance asset management.
A lot of those techniques are, extremely advanced. I mean, how quickly do you see them being rolled out in a practical sense?
I think these are being used already. These are not necessarily things that we're waiting for. There are many companies that are already using these. I think the question is, how do we more widely use them? And how do we transform the way we do maintenance across organizations, across sectors, across the nation? I think it's more the scalability question.
Right. We've got quite a relevant question that's come in, and we're going to do a bit of experimentation now. We're going to try and get Magdi to speak to us. A bit of fun. Here we go. And therefore, if Magdi can speak to us, we can go ahead. Magdi, are you there?
Yeah. Can you hear me?
Yes, we can.
Yeah, good. Good morning, all, and pleasure meeting you all. Thank you very much for this opportunity. Well, my question is what are the risks associated with the implementing maintenance 4.0? Specifically, what are concerns regarding the security of that data transmission? This is the main question. We talked about the beneficial of implementing digital technology, but we need what are the risks? So to clarify that, It would be great if you can give me more information regarding this question. Thank you very much.
Thank you. John, do you want to take that first, and then we'll
Yeah.
ask the others as well?
Yeah, I mean, it's an interesting way to look at it. I think the risks probably lie in the process of collecting data. We're becoming more and more dependent on sensors, but sensors are not always reliable. So how do we deal with that? There's another aspect in terms of how do we process data? So there's a lot of concerns by many companies about machine learning being a black box approach. And in that sort of context, how do you justify, how do you evaluate the recommendations coming from machine learning? There's some concerns there. Not all machine learning based methods are black box, but there's some perceived risks. And I think the other thing around cybersecurity is really interesting as well, in terms of building, particularly where we see cybersecurity is where there's some kind of interoperability challenge, where software is not communicating to another type of software, and then there's some gaps. And then we have this interoperability issue where cybersecurity, the risk, the threat grows. But if we haven't designed cybersecurity into the system, we have a huge challenge in that it's harder to deal with, and it's more costly to deal with. But there is a huge risk in terms of cybersecurity, and I think we need to think of that. But that if we sort of look at the pros and cons, I personally see the pros a lot higher if I compare it to the cons. But we need to really take adequate measures for cybersecurity risks.
Thank you. Richard.
Yeah, I think, cybersecurity is, fantastic and important. Our Chief Information Security Officer, has got a range of horror stories that he can share about businesses that have, been subjected to cyber attack through their industrial IoT, infrastructure. And I think, first of all is, a lot of businesses believe that they have got security through obscurity and go, we're not going to connect the internet because we're secure. The reality of a lot of those businesses when they get true audits done is actually there's a whole lot of vulnerabilities within their operational technology network that they're unaware of. And often having an IoT strategy and bringing it in control can make your site more secure from a security perspective, not less, because suddenly you've got governance around it. I think when you're looking at technology partners to work with, you've got to be cognizant that security comes, from three things. First of all, you've got to have the right software built to the right best practices, and that software needs to be regularly penetration tested to make sure that friendly hackers come and try and get into it, and then that identifies vulnerabilities, allowing the software vendors to address those vulnerabilities. It's got to be secure from a hardware perspective, so things like putting data diodes in to make sure that traffic can only flow one way, monitoring traffic on the network, but probably most importantly of all, you've got to get the procedural bit right. And so organizations that have embraced and are accredited to ISO 27001 have got clear ways of working to ensure that they're managing that cybersecurity. So you've got to look from a software, a hardware, and a procedural perspective to make sure that you've got the right security around that data, and you're not generating new attack vectors into your site.
I think the interesting point you bring out there is that the mere process of introducing digital maintenance, or I guess digital anything, forces you to focus on the cybersecurity issues, so you can get a benefit rather than a risk, which is a very good way of looking at it, I guess. David, what's your take on the risks of maintenance 4.0?
Well, I think one of the things we've talked about is that digital mindset, digital strategy. A lot of businesses go and do something digital, whether that be maintenance, whether that be operating technology. They put a system in to solve a problem, and really it's back to understanding what you want to do as a business and building that digital strategy across all aspects of the business. so that you've built that whole architecture of what data do you want to collect for what systems are going to manage which areas of information, and then you've built looking at how you integrate those systems so the information flows across. A lot of the time, as John's already saying, that some systems don't communicate. That tends to be that they've been bought in isolation, and without that overall strategy, you're not looking at how these systems are going to communicate, how you're going to collect your data, how are you going to secure it. And it's those sort of API links or tenuous links that you're trying to get to push data from one system to another that create that risk. You're collecting the wrong data, or you're not using the data. So you really need to sort of understand what you want to do, what you want to measure, and how you're going to collect that information and make it usable data. Because a lot of the things we talk about, yes, cybersecurity, absolutely. It's your firewalls through various systems. If you're looking at aerospace or military and other areas, you're looking at data segregation. So what data shows how a part's made, and you've got to isolate. So it's how you sometimes anonymize some of the data so you can still use it. So you have to look at what you need as a business, but collecting the right data and making it usable data, because if you're not, you've got to go in the right way, the right approach. If you're not getting the right information, using it correctly, one of the biggest risks is that you don't realize the benefits because you haven't implemented it correctly. And actually it starts to fail because then the leadership look at it and go, well, that was a waste of time. We're not really getting any value from it. So you really need to understand what you want to do, why you want to do it, what data you want to collect, how you're going to collect it, who needs to see it, and what you're going to do with it so that you understand how to get the value from it.
I guess, there's another type of risk as well, isn't there? Which is not risks to bringing down your business as such, but the commercial value of the data and how you protect that. Is that something that needs to be considered to a greater degree?
You need an integrated, security management approach. Information security is about every bit of data that exists inside your factory, your business. Clearly the whole GDPR piece is the most obvious and legally vulnerable piece, but it's got to be thought about at a holistic level. And you need people for whom information security is their job to think about this for you. It's not for the faint-hearted. And my experience is when you talk to the people for whom it's their job, they're really open to the concept of data interoperability and IoT, because they get the controls that need to be put in place to manage it. It's actually the people who don't have the understanding who are the ones who are most likely to take the just say no approach.
And I think one of the other pieces is as well, you're putting all these systems in, you're gathering all this information, but we talked before about the right people to use that data with the right skills to actually do something with it. Because collecting tons of data, and if it's not the right data in the right format, it's just like a children's ball pit. There's just lots of bits of information, but you can't get it and link it together. So he's collecting it in the right way and the right people to do that. So it's the right skills to sort of capture that data, manipulate the data, understand it. What do you want to do with it? And that's really useful.
I'd also reframe the question in the sense of what is the risk of not digitalizing? Can you actually stay stagnating without these technologies?
Yeah. I think that was brought across very, very strongly by the point that Richard was making earlier. The cost of not doing it is prohibitive, isn't it?
Yep.
Talking about your kind of advanced technologies, your digital twins and your augmented reality, where's the boundary between those technologies and artificial intelligence, and what role is that likely to play?
I'd actually like to propose that these are designed in a very integrated manner. So I wouldn't necessarily suggest that these are separate things, separate initiatives. They all feed into each other. If I've got a good data management process, I probably can improve the way I'm going to use augmented reality. I'm going to improve the way I'm doing machine learning, and same for digital twins. So if I've got a digital twin, I probably have the links between data and models a lot better defined, which means I probably can visualize data much better. So things like dashboards, things like augmented reality become much more feasible, potentially real time. So I think when you're building a digital strategy, we need to look at these technologies holistically and not necessarily think, I'm going to build a machine learning model. I think it has to be about the overall value that I'm trying to create and work backwards in terms of the different things that could contribute to that.
I think as well, some of the digital twin, certainly for new lines, sustainability, energy management, energy monitoring, be able to create a replica of your factory in a digital environment that you can feed in the energy usage. You can start looking at optimizing your production from that digital twin, not just about producing the parts at the right rate, but actually looking at the energy monitoring and energy management element for sustainability. You look at air pressure and how much, air pressure as an example, how much it costs running compressors. Well, you can look at what air pressure for value, not just about running your compressors flat out to just keep all your machines going, but you can start looking at optimizing your production for the best value for the business and using that type of data from a digital twin to really understand your energy usage for putting a manufacturing line. And again, if you know the usage, you can build it into a digital twin for legacy equipment as well.
Yeah. Okay. I mean, I guess artificial intelligence is when the machines start to think for themselves and they decide what condition monitoring strategy is necessary. So perhaps we're not quite there yet. There's a question that I'd like to take now, which is from Rob, and it says, can augmented reality be used as a better access dashboard, allowing easier and more detailed analysis of data? Or is this too simple?
Yeah, I mean, if I sort of jump in, I think from my perspective, augmented reality could be used as a better access dashboard. We're doing, for example, a PhD project at the moment where we're trying to define what does the future maintainer look like. And I think in that context, we've been using augmented reality as the means to access any type of data where the person needs it. So in that context, if we're thinking of the target is to improve efficiency in any given task, having information accessible would contribute to improving the efficiency. So I don't think it's necessarily too simple. I think it really depends on the task, depends on the availability of the data or the need for the data. All those kind of things really are key. But I do think augmented reality does have the potential to be, well, as one of its features, to be a dashboard in that process.
Excellent.
Sorry,
Richard. Yeah.
Just to build on John's point, I think the key word for me in what John said is potential. I think the technology is exciting, but it's not at the stage yet where you could mass deploy it into a production environment. It's the headsets aren't there, the processing capability is not there, but you can see where it's going to go and how the gaming industry is going to drive it that way. It's 5 to 10 years out, not 2 to 3 years out.
Yeah, I mean,
and if you go back to the survey, sorry, John.
Yeah, no, I mean, I think with Richard, I agree. I think with augmented reality at the minute, if you want to present that sort of dashboard feature with data that's available, that's easily accessible, you can do that. But will it add a lot of value? I think there's questions there. I think the kind of context we're seeing that it's probably more useful is where it's a complex task. It's difficult to address, and potentially you need your highly experienced people thinking about, in that kind of context, how do we maybe de-skill these complex tasks? Augmented reality could help there. And also in situations where, let's say, an asset doesn't break down very often, augmented reality could be the assistant trying to solve the problem where people don't necessarily remember the process, and it's giving them those nudges, giving them the kind of step-by-step guidance. I think in those kind of environments, augmented reality can be powerful. I think at the moment, it's very costly to create a maintenance application for everything using augmented reality.
Okay, Richard, I did promise you on Friday afternoon that I'd come back to you and give you the opportunity to talk a bit more about the techie side. So this is probably an opportunity to do that.
Yeah, I mean, I think we've actually covered a lot of ground in the last hour and 10 minutes. David's talked about the sensors, of actually collecting the data. We've touched a little bit on getting data out of existing legacy machines and moving that into a central repository. So that challenge of getting the data from the machine to the edge, we've covered off. We've talked a little bit, in terms of both the security side of things about getting the data off-site and some of the challenges there. And John's talked a lot about what to do with the data that once you've got it in there. But I think for me, none of these are easy challenges to solve. You do need expertise in order to help you do it. They can be solved, very cost effectively, but you do need to bring in, subject matter experts to help you do it. So, I think, my encouragement would be is, don't try and turn yourselves into, cloud computing and AI experts, because you're not going to manage it. Focus on being maintenance professionals, and then look for technology partners and delivery partners who can help advise you on the right, the right tool to use, the right techniques to use. And I think just, one last thing on the data side of things is, I'd endorse everything John said about the potential of the AI systems and digital twins, etc. But you can still do a lot with not very much, from data. And too many people leap straight to the end state of trying to be clever and miss out. Statistical process control was and is, a fantastic technique for looking at anomalies in data. You can do a simple control chart. You can just now do it digitally rather than on a piece of graph paper. But you can get just as much insight now as when I was plotting them in 1992 as a young graduate.
I think the other piece as well with that is, if you just look at the survey and the amount of companies that don't really have a structured maintenance plan and a method of monitoring the machines at the moment, a lot of businesses have got nothing, and absolutely understand the sort of augmented reality and elements to support, but there's a lot that haven't even got the basics yet, and just getting into gathering some information at a simple level, as Richard just said, just start to visualize, because the benefits that businesses will see actually generates the extra finances from the savings to start reinvesting. And it's that reinvesting to keep growing. You can't go and put sensors on every solitary machine and all of a sudden you've got a fully integrated system that predicts everything, because it's too much to start with. So, pick your critical machines, but there's plenty of businesses that just haven't got anything yet, or have got something really basic. So just start building. It's, take one step at a time, and you'll really then start to see some value.
Yeah, I think that return on investment, and therefore being able to continually reinvest, is the key, isn't it? Because, it's the old adage of start small, think big, scale fast. And if you follow that pattern, you should be saving a lot of this £5,000 a second or whatever it is in the future, and hopefully not too soon. Well, we're hitting the kind of 75-minute mark, which is usually an indicator. Just one answer to a question posted in the chat is that yes, we do send out an on-demand link. So those of you who would like to listen to this again, you will be able to. And for those of us who unfortunately missed it, they will also receive it. Andy mentioned the podcast, so we send it out as a podcast as well. Well, this is a bit like Hotel California. So once you join us, you'll never leave. And the webinar is actually the start, so that we will keep you in contact with our registrants and anybody else who wants to discuss any points, mainly through LinkedIn as well. So there's a lot of ways to continue to ask questions of our experts, and we'll hopefully our experts will be happy with that. I'd like to finish with two questions. One is a specific question about an application, which is nice, and the second one is a more general one from Aaron. And if Aaron's still on the call, I'll ask him to come on board and ask it himself. But first of all, let's deal with the more specific one, which is an example for a transformer oil leakage, which can be detected by oil level sensors or switches, and small level leakages can be detected after certain levels down, not at the time of leakage started. I'm not quite clear what that means. For an electrical panel, carbon was deposited on the contactor after operation of switching, so can only visualize, or periodic maintenance may be required. So essentially we're looking at a transformer oil leakage problem, and how can that be solved by sensors or switches, and how would maintenance 4.0 help?
I'll give a go first. I'm a decent condition monitoring engineer. Fortunately, I have in my team people who are much better condition monitoring engineers than I am. I think you've clearly got the opportunity to look at level in there. I would be looking at putting some continuous monitoring of the oil quality as well. So putting a sensor inside the oil bar to look at both the chemical composition of the oil and any contaminants, and potentially you could be looking at putting a camera on the system as well to look at leaks. And smart cameras. I was on a presentation the other day. One of the other presenters was talking about the smart camera as the universal sensor, because there's so much you can do with a smart camera. So that'll be my approach: bit of level switching, bit of level sensing, a bit of monitoring of the oil itself inside the transformer, and probably a camera.
Brilliant answer. Anyone want to add anything to that? So it sounds like a pretty comprehensive response, and maybe Richard could talk to our questioner and afterwards if they need any further help. Meanwhile, Richard's colleague John has just dropped in an interesting stat from Make UK, which says that 88% of UK manufacturers have implemented some form of Industry 4.0 technology, but only 15% have fully adopted it. So that's food for thought in many different dimensions. So let's come back to Aaron's question, and he's on the line, so I don't need to read it for him. Aaron, off you go.
Hi everyone. I mean, I've spoken to many manufacturers over the last 6 months or so, and investing in digital technologies for maintenance have been justified as a means of helping with a company's carbon footprint and helping with sustainability targets. Are you seeing this as an increasing reason for investment in digital maintenance technologies?
Absolutely. As we said, the cost of air pressure, power, it just understanding whether your machines are running efficiently, what power consumption, even down to silly things that, where people turning them off when they're supposed to. The sustainability element, the cost of energy now, it's more so than ever around understanding it, people running compressors and not turning compressors off, and just the cost of that, motors running, machines idling. There's a huge amount, but then it's just looking at efficiency, feed rates and cutting rates and running on machines. If you can sense how much energy has been used, and you can start to optimize your cutting patterns. Digital twins can give you some of that element as well, where if you can build the model correctly, but just understanding cutting patterns and if the feed rates to optimize the amount of loading that the motor's going through for the power you're using. So it's becoming bigger all the time, really, energy now.
So would you say then it's going to be one of the main reasons to justify maintenance and digital investment effectively? Because although a lot of people have struggled to get through based on, especially SMEs, on a cost simply by saying, oh, we need this technology because it's what we need to do for the future. And companies will come back and say, their MDs may say, well, yeah, it's a great thing, but we just can't justify it. But if you go back and you actually said, well, if we don't do this, if we do this, we could actually save money, we can actually improve our carbon footprint, etc., etc. And then in the future, if we don't have that ability to prove what we're actually doing, it will actually cost more for the company.
I think we need to really focus on how do we make justifications, these kind of return on investment analysis, and wider than that, really. I think we need processes to do that, because we're missing a lot of opportunities because we're not able to justify in the right manner.
Okay. Yeah.
I think maintenance and energy optimization are both subsets of the broader topic of asset management. A well-maintained, efficient machine normally consumes less power. A fridge compressor running at poor efficiency is probably going to have a maintenance-induced, maintenance-related failure at some point as well. So, monitoring energy is one of your condition monitoring techniques. The advantage of energy reduction is, of course, you can cash it up straight away, whereas some of the other CM techniques are much more of an upfront investment and a cost avoidance rather than a cost saving. Our customer number one with RS Industria was a guy called Ben. He's the site engineer at Kerry Foods in Tenbury Wells, and he's now 2 years into his digitization journey. And he started out in utility management, focusing on his utility consumption, and has used that as the business lever to then allow him to invest in much more broadly in other areas of the digitization of his maintenance function.
Excellent. Okay, thanks.
Excellent. Well, thank you very much. It would be good if we could, promote industry's role in solving net zero activities, because, wrongly, industry often gets a bad press when it comes to environmental issues, whereas I think we actually have a massive contribution to make, and perhaps we're better placed than many politicians are to use technology to take the whole issue of saving the planet forward. Anyway, that's my political message for the day. I think with that, I will thank our speakers very much, and I'm sure our attendees will give you all a virtual round of applause for your efforts this morning, which was excellent, very informative. Came at a number of issues from different angles, which is excellent. So thank you very much for that, and thank you everyone for attending. And we'll be in touch in due course. I think our next Talking Industry actually is in the autumn, so we've got a couple of months off over the summer, and we'll look forward to seeing everybody then. So thank you very much again. Goodbye, everybody.